So in this video I'm going to go first quickly over the homework of section B. So first question, you are given the new node, we're given the size, and it's important to see this the alternative hypothesis that the mu is less than 25. So I want to see how I'm going to translate this into the calculator. Mu less than 25 is going to be mu less than mu naught, and now I'm going to go in my calculator. We need to go to stats, tests, and we go down to option 2, which is the t-test. Now I'm gonna use stats, and we have that r is 25, we have that our n is 36, and we have that our sample mean is 23.75, and we have that the sample standard deviation S is 3.97. so that's all. And we have to be careful about your choice here. We need that m is less than m naught, so it's the middle choice. And we calculate, and that's our answer. We have negative 1.89 and p-value 0.0336. So I'm rounding my answers, and you see my answers here. And I want you to notice that I'm going to do this kind of writing. Since p-value is about, I have to write this about 0.0336, I forgot this, 336, which is less than 0.05, which is the alpha value. That's how I want you to write for your IAs also. We reject H0 in favor of H1. Question number 2. I'm going to go fast because you have already solved it. So I always write my information here. Then I write my hypothesis here, and I'm careful to put this to make sure that mu greater than 80 for the GDC it's going to be translated in this way, and I'm going to go into my GDC. Stats, test, t-test, going to go at 80. The sample mean is 83.1, and the sample standard deviation is 12.9, and our sample size is 200, and then we need to choose the last option, that is bigger than mu is bigger than mu 0, calculate, and we find our answer. I'm rounding my answers from my GDC to 3 significant figures here, and now the way I'm going to write is the following. Since p-value is about 0.000405, which is less than 0.01, which is the alpha value, we reject H0 in favor of H1. So we conclude that mu greater than 80 at the 1% significance level. In question number 3, again, after you read the problem, you put a summary here, and I would like you to write this on your exams also. So after this information, it's important to translate the alternative hypothesis mu less than 100 on the calculator. That's going to be the option mu less than m naught. So I go into my calculator, go to stats, test, t-test, option 2, and then we go and then mu naught is 100, sample is 99.4, and sample standard deviation is 1.6, the sample is 40, and the option is the middle one, smaller than mu naught, calculate, and that's your answer. and I get my values in 3 significant, and I'm writing my answer. Since p-value is about 0.0114, which is less than 0.05, which is the alpha value, we reject H naught in favor of H1 of the alternative hypothesis. Thus, the customer's claim is valid at a 5% level of significance, that the bags have been lighter in recent purchases. Question number 4, again you write the summary of the given things that the problem has given you. You're writing the two hypotheses, and it's important to translate the alternate hypothesis into the correct symbol for the calculator, which is basically this is a two-tailed hypothesis test. So you're choosing the option mu different than 20.3, and then I have to go into my calculator, go to stats, test, t-test. I'm going to put that our mu naught is 20.3, our sample is 19.2, the sample standard deviation is 2.89, the sample size is 80, and for the alternative hypothesis, the first option, calculate, and we have our answer. You go into the calculator and you round to 3 significant figures. So here, since the p-value is about 0.00104, which is less than 0.05, which is the alpha value, we reject the H naught in favor of H1. Thus, you get the following result, that the herd has changed between 2015 and 2019 at the 5% level of significance. And then for question number 5, again you write the summary statistic, and then you write the two hypotheses, and then you need to go into your calculator, go to stats, tests, t-test, and now we go to the mu naught is 2.00, the sample mean is 2.04, the sample standard deviation is 0.09, the sample size is 15, and we want the first option that they are different, the alternative is that they're different, it's a two-tailed alternative hypothesis test, calculate, and we have our answer. We write the results from the calculator here, I write with the significant figures, and since p-value is about 0.105, which is greater than 0.02, we accept a null hypothesis. So the result, the conclusion is that it's not justified to adjust the machine. Question number 6 is the first one that has two significant differences. First of all, I'm going to take the time to show it to you that the data that we have here is in grams, and we were given that the mu naught was in kilograms, so I have to change this into grams, so everything is in grams. And another important thing is how to enter the data into the calculator. So let's go. Of course I write my my two hypotheses, and I'm sure that I know how to translate it, but let's go into the calculator. Question number 6, I go to stats. I need to first enter my data, so edit, and I have my data here in terms of grams, so 1001, 998, 999, 1002, 1001, 1003, 1002, and 1002. Then I go to stats, tests, t-test. So I'm careful now to choose data this time, and I'm careful to choose, instead of 1 kilogram, and put 1000 grams. So that's the key here. In my list 1, frequency 1, I choose my second field choice and I go to calculate, and this is my answer. So now that you saw how this was done, I round my answers to 3 significant figures and I write my conclusion here that we have insufficient evidence to support the underfilling claim of at the 1% level of significance. So that's a good phrase to know that we have insufficient evidence to support the underfilling claim. For question number 7, the first part, so it's very similar like the previous problem, we will have to enter the data manually, but for part A, explain why it is reasonable to assume that the carriage weights are normally distributed. I have included here the answer from the back of the book, but the important part is that I was looking for is part B, so you put your statistics, your information. It's important after you put your hypothesis to see how you're going to interpret the hypothesis on the calculator, that mu is greater than mu not, and let's go into the calculator. I have to first enter my data, so I go to edit, enter, and I have entered already the first 19 of them, so I'm going to go and enter the last one, which is 47.2. Go now to start test, t-test. So I'm going to go to data, and then for the new node I need to put 50. This one I have, and now I have to select the option, the last option, greater than my number, which is 50 here. Calculate, and this is my answer. So we transfer the answer from the calculator here and we make our conclusion. The next part is a TOK situation, so I really want you to go into the book, and definitely I want you to really read this part. This is very important. I'm just going to read to you a couple of important questions, TOK questions. How is the term significant is used? What is significant? So is saying that the result is significant the same as saying it is true? And what is the connection that you can make with COVID-19 and vaccine effectiveness? So if they say that they find a vaccine that is 95, that's working, and we are kind of know that our results are valid and significant at the 5% level of significance, what does that mean? Is that enough? Now the next thing I want you to do is I want you to definitely read section C, which is going to be the 2 sample t-test. Not very difficult. We're just going to have 2 different samples with 2 different sample means and 2 different sample standard deviations and 2 different sample sizes, and we're going to kind of see what happens from one to the second. We're going to write again our hypothesis in the same way as before. The first mean is the same as the second mean. Sometimes they write them as mu1 minus mu2, the first mean minus the second mean is 0, or the other way around. Usually I prefer this one. The process on the calculator is very similar, but it's outlined on page 393, so go and read it. But I'm going to show you also in an example in a little while. So after you read the calculator process, go over example 3 in the book using the calculator. A very important thing is when you go to use the 2 sample test, you have an option, so you have a definite option at the bottom that says pooled. So in our course we will always use the pooled 2 sample t-test. Okay, we will always use, you will always have to click yes on this option, always. So I'm going to go over the first question, which is the question that we started the topic. Actually, I'm going to go over it so you can do the homework for tomorrow. First, I'm going to separate so I have the first sample here. So I have that the size is 50. I have the first sample mean and the first standard deviation, and I have the second sample. On the second sample also I have the size, the mean, and the sample standard deviation. Always I have the significance level before I start, and I write my hypothesis, and I want to see if the second mean is higher than the first one. And let me go to my calculator. Test. Now this time we go to two sample t-test. So we're going to go to stats, and now the first sample mean is 106.3. The first sample standard deviation is 12.41, and the first sample size is 50. Now the second sample mean is 110.1. The second sample standard deviation is 13.1, and the second sample size is 65. Now we are looking for the choice is going to be mu1 is less than mu2, and for our purposes we will always choose yes. Our pool data is always going to be yes. We go down, we calculate, and this is our answer. P value 0.0587, and that's it. My calculator, I found that my result P is about 0.0587, and I can make the conclusion. So that's the way that you can go and do the homework.